So today's date is 2/7/17. I wasn't finished. Trying to see if you're paying attention. Good job. Alright, let's just focus on the math. Okay. Identity property. Identity property. ID. What's ID mean? Your information. It's who you are, right? It's your identity, right? No matter what we, no matter what we, might dress like, or on Halloween what we might dress up as, we are still, at the end of the day, who we are, right? Identity doesn't change. You are who you are. That doesn't change. So an identity property, same thing. Whatever the number is, it doesn't change. If I start with a 5, I end with a 5. If I start with a -3, I end with a -3. It doesn't change. If I start with an X, what do I end up with? An X. Okay? Cool. So there's two properties. One is the identity property of, let's start with addition. Cool. So in addition, what do I add to a number to keep it exactly the same? So pick a number. Okay, 5. What do I add to 5 to keep it 5? 0, right? Exactly. So if I start with 5, how do I keep it a 5? Plus 0. So for identity property of addition, you add 0. Number 2. Yeah. Identity property. Yes. Identity property of multiplication. Okay. Pick a number. Okay, I heard 7. What number do I multiply 7 by to keep it a 7? 1. Very good. So write that down. For identity property of multiplication, you're going to multiply by 1. All right, let's just do some examples so you really understand this. All right. Yeah. Again, Alex allows you to learn stuff faster than I'm teaching it. And then so when I officially teach it, you're not like, wow, this is brand new. They're just like, oh, I already seen this, so now I fully understand it. You review instead of learning it like brand new. Right? Some of you are sitting there going like, oh, okay, identity, property, multiplication, huh? What? And some of you are like, oh, that makes sense. All right. So 5 plus, and then make a rectangle equals 5. Cool. But since these are not 90-degree angles, okay, so 5 plus 0 equals 5. What if it's -7 plus what equals -7? So even if it's a negative, John, it's still that 0. Right. What if, the rectangle comes first, plus 3 equals 3? Okay. So this is an example of the identity property. You're adding 0. So when you see you're adding 0, you're talking about the identity property. All right, for multiplication. So 7 times what equals 7? 1. Right? What if it's, a -3 times what equals -3? Times 1. All right, write those examples down. So this is very easy, right? All you have to remember is like, oh, when I'm adding by 0. When I'm multiplying by 1. Now, these are the hard ones. The next one. true or false? You're writing this down, guys. No, well, I'm asking you, true or false? Is this an example of the identity property? Identity property in multiplication says you have to multiply by 1. Are we multiplying by 1? How so? Nice, gentlemen. Very nice. This is really what? A 1. I like to call it a 1 in disguise. It's hidden. You know, you guys don't see it right away. It's like 3 over 3 is 1, but it's like in disguise. So this is really 3 over 3 times 7. But wait, is this 7? We'll simplify it. What's 21 divided by 3? So it's true. But it's all in disguise. Yeah, you gotta be a detective. You see this, let's say you see it on the worksheet and I'm going to say, hey, true or false. You might say it's false and you're like, well, no, Miss Amelie said it was really easy. All I have to do is times 1. Yeah, but sometimes they disguise it and you have to figure it out. Got it? Okay, again, I could say, I can go, oh, negative 3 times 4 over 4 is equal to negative 12 over 4. And you might sit there going like, oh, that's a false. It's not identity because I'm not multiplying by 1. But what is this really equal to? 1 times negative 3 is equal to, and then this is equal to what? Negative 3. Right? It's in disguise. Got it? Okay, this one's super in disguise. David, can we please? Is it true? How do you know it's true? What is 5 over 5 really equal to? So this is really 1 times 3 over 2. But is this 3 over 2? What do I divide by? 5. And what do you get? So these are the ones that are like, they're tricky. They're like, oh no, it's a fraction. It can't work. And it's like, yeah, it can.